So PA5, sorry, PA1, question number 5. This is the question.
Yeah, yes, sir. I'm little confused about this negative feedback thing.
So yes, so
Can
this is
you?
the question. So we in the question, what is it is given that for the value of k is equal to 6, the circuit behave as a negative feedback. Okay, and we have to say that either true or false. Okay, either yes or no. So let's see if I put the value of f. This is my f. Now I put the value of k here. So k minus 10 upon k square minus 3k minus 7. I put k is equal to 6. So 6 minus 10 upon 36 minus 18 minus 7. Okay, so that is minus 4 upon 18 and 7,
Right.
25 and 36, so 11. Okay, so now if I put a as a minus 4 by 11. Clear? Now what I
Yes.
have to do, I have to break, this is my loop. I have to break this loop, apply some positive voltage. Okay, so when the signal will be go in this direction, so here the signal will be the in positive direction. If it multiply with the negative side, so here the signal position is negative. Okay, so that particular negative voltage will be negative multiply by the negative, so it become a positive, and positive and V in voltage both will be added, so the signal will be in positive. Okay, now if this positive multiply with the minus 20, if you see that it is a minus 20, so if this positive voltage multiply with the negative number, so we are getting a negative value. We are not saying what is the amount of that particularly negative or positive value. We are saying only the magnitude is positive or negative. Maybe it is a point 0.1, maybe it is a point 0.10, or maybe it is a 1, 10, any value. Doesn't matter, but the only thing is that we are only checking what is the magnitude is positive or negative. Okay. Now if you see here at the output where we break the loop, we apply some positive voltage, and when the from the feedback it will be coming there, that particularly will be coming with the negative. Okay, so that means there is a phase shift, and phase shift of 180. Okay, so we can say this is behave as a negative feedback.
Okay,
Clear?
sir. Oh, clear, sir. Actually, in graded assignment also there is a one question of this kind. Question number 7.
Yeah.
I'm just confused in both of these. I just
Mhm.
realized that in that question there is no negative sign. It is positive sign.
Okay. Yeah, this
Yeah.
question is
Thank you,
also.
sir.
Can I solve that question also?
No need, sir. So I
Okay.
got the idea.
This is the question
Yeah.
number 7.
Here there is no negative sign, right?
Yeah, here
There is
there is no
only
negative
positive
sign.
sign.
So if the value of f is negative, I take
Uh,
to both cases. So the value of x is either negative or a positive. Okay. So if I break the loop, increase the voltage. So when it is a negative, we are getting a negative voltage. When it become positive, we are getting a positive voltage. Now both voltage will be added here. Okay. So if negative voltage will be added, so maybe my signal will be the negative. And if positive voltage will be added, I sure that my voltage will be in positive. Now if negative signal multiply with negative, we are getting positive, and positive signal multiply with negative, we are getting a negative. So here this particularly is no phase shift. Okay, and this one we are saying that 180 degree phase shift. So what is the requirement? The required thing is that if I am required 180 phase shift, so this particularly F value should be positive. Okay. Now what we are doing, we are checking. So we have a k minus 10 upon k square minus 5k minus 7. K minus 10 upon k square minus 5k minus 7, and k value is 5. Okay, so 5 minus 10 divided by 25 minus 25 minus 7. So it is a minus 5 divided by minus 7. So both will be cancelled out. So 5 by 7. So that means if f value is positive, we are getting a 180 phase shift. If f value is negative, we are getting a no phase shift. Okay, so that means this particularly is a negative figure. Okay. Any other doubt?
And also the fifth one, graded
Uh,
assignment one, fifth one.
Graded assignment one, fifth one.
Yes, sir.
This is the condition. This is the question. Now we say that if we check that there are two particularly output relation with respect to the E, because if you check the options, so options says that only the relation between V out and E is important. Okay, because the all option will be either V out increase, E increase, V out increase, E decrease. So these type of option. That means we have to maintain a relationship between V out and E. Okay, now if you see in this diagram, so two types of relation are there. One is direct, one relation is that E multiplied by A, that is V out, that we are getting direct. Okay, and second relation is that V out, if I multiply with this V out with F, so F time V out. Okay, and this signal will be subtract from V in, so V in minus F time V out, that is E. This is the second. Okay, now point is that from equation 1 we can say the V out is a directly function of E from equation 1, and from equation 2 I can say E is a function of V out and V in, because F is the constant, but V in and V out, it will be depend on both V in and V out. Clear? Now from equation 1 I can say if E increase, V out increase, and if E decrease, V out decrease. Okay, but in equation 2 I can't say that if F V out increase, E decrease. Can't say that. Why? Because E is not only dependent on the V out, that is also dependent on the V in. So without knowing the value of V in, we can't say that if V out increase, E will be decreased. Maybe V in is also decreased. Okay, if V out is increased, maybe V in is also increased or decrease, E automatically decrease. Okay, so I can't say that this particularly equation 2 will be giving me the direct relation between E and V out, that E is dependent on V out as well as the V in. Okay, so we can't say this thing that V out is increases, E decrease. Maybe possible that V out increase, E increase, or maybe possible the E decrease. Similarly, if V out decrease, maybe E increase or maybe E decrease. That is all dependent on the VA. So that's why equation 2 is not a relation, should not show the relationship between E and V out. Okay, so we are not considering the equation 2. We are not considering the equation 2. Why? Because it is also dependent on V. So for the relation between E and V out, we consider the equation 1. And according to equation 1, if E increase, V out increase. If E decrease, V out decrease. These are the two relations. And in the question, they are asking the false relation. So that means if V increase, V out decrease. If E decrease, V out decrease. Okay, so only the thing is that you have to check in the equation 2, it is not a dependent only on the V out. That is also dependent on the E. Okay, so most of the persons will be consider the equation 2 also. And according to equation 2, they say that if V out increase, E decrease. If V out decrease, E increase. But that is not true. Clear?
Yes, sir.
So that is a question number 5. Any other doubts? So practice assignment 1, any doubt? And graded assignment 1, any doubt? No doubts? Student, better that you can speak either doubts or no doubts.
So week 2 graded assignment question number 11 and 12.
Which one?
Week 2 graded assignment.
Okay, week 2 graded assignment. Week 2 grade assignment. This is the question number 11. Question number 12. Okay, now if you see that question number 11 is also dependent on question number 10. Okay, and the question number 10 says that you have to identify the where the 5 volt will be connected. That particularly terminal is the positive terminal or negative terminal, or basically inverting terminal or non-inverting terminal. This is the question. Okay, so first of all, we identify that one. So if we go from the bottom down circuit, now thing is that if we are getting this voltage is greater, this voltage, like for example, this is the VA, this is the VB. Okay, if I say that VA is greater than VB, so that means VA is inverting terminal. Similarly, if I say that VB is greater than VA, so that means VB is a inverting terminal. Why it's so? Because which voltage is higher? with respect to this, that one we are getting a higher negative magnitude at the output of the operation amplifier. Okay,
Yes, sir.
both will be the dependent on the differential, that is the differential mode. So basically output, what we are getting, the output V out is nothing but A times of V positive minus V negative. Okay, so if V positive is greater than V negative, so V out is positive. Okay, if we apply the signal in the positive and we are getting the output in the positive, so we can say this, there is no phase shift. Okay, so the condition is that always V negative voltage is higher, so we are getting output voltage is a negative, and if output voltage is negative, we are saying that it is a 180-degree phase shift, or that is a negative feedback. Clear? So always consider the terminal where the voltage is higher. So we are getting the negative output voltage. Now, if I check the VB voltage, so here we are getting the V naught. Okay, if the V naught will be passed, the current will be passed from this V naught to this ground. So that means what is the current is flowing? I say this is the I current. So I current is what? V naught minus 0 divided by 20K. Okay, and what is the voltage drop across this resistor is? So VB I say, because VB is nothing but the voltage drop across this resistor. So VB is what? I multiply by 10K. Okay, so V naught minus 0 divided by 20K into 10K. So we are getting a V naught by 2. So that means this voltage will be nothing but V naught by. Clear? Now again, if I am taking this output push terminal, so that V naught and this 5 volt is also added in that one. Okay, that 5 volt is also added this in this one. Why? Because the polarity is negative to positive. So that particularly V naught plus 5. Okay, and all voltage will be drop across this resistor. Why? Because after that there is the ground. So the voltage at this point is what? V naught plus 5. Okay, now which voltage is higher? V naught by 2 or V naught plus 5 volt?
V naught plus 5 volt.
V naught plus 5. So we can say this terminal is negative, this terminal is positive. Okay, so this is the question number 10. Now in the question number 11, we are getting both voltages. Now what we are do? We know that if it is it operate in the negative feedback, so the voltage at a positive terminal is equal to the voltage at negative terminal because of the virtual ground. Because of virtual ground. Now what is VVA? V naught plus 5. And what is VB? V naught by 2. If I solve this one, so I say that V naught minus V naught by 2 is equal to minus 5 volt, or V naught by 2 is equal to minus 5 volt. That means V naught is equal to minus 10 volt. Okay.
Yes, sir.
Now it is clear. Question number 11.
Yes, sir.
Okay. Now we go to the question number 12. They are saying the voltage at the Vx point. So we know that this operation amplifier will be working in a negative feedback. So that means there is no particularly current will be, no output is there. The output will be there at this point. Why? Because all current will be passed through the feedback circuit. So no current will be passed towards the operation amplifier. So if no current is there, that means the voltage is also not there because of this operation amplifier. Okay. So what is my V naught? 2 volt I apply, and that is the inverting amplifier, sorry, non-inverting amplifier. Why? Because that particular 2 volt will be applied on a positive terminal. So 2 multiplied by gain of that non-inverting is 1 plus RF by R. So that is 2 multiplied by 1 plus what is RF? 8, and what is R1? 5. So 8 by 5. So 2 multiplied by 1 plus 1.6, that is 5.2 volts. So my V naught is 5.2 volt. Now, if I say that we are know this voltage, this is my feedback. So can I get Vx voltage? Vx. So my V naught is nothing but, because of the second operation amplifier, my V naught is nothing but Vx times 1 plus, because it is again a non-inverting amplifier. So 1 plus RF. RF is what? 20, and R1 is 4. So 20 divided by 4. Okay, and V naught is what? 5.2. So Vx times 5, 6 is equal to 5.2 volts. So that means Vx is what? 5.2 divided by 6. So 0. Around 866 volt. Okay. Now there is, I think you have a doubt that if this operation amplifier is not passing any current, so how this Vx will appear?
Yes.
Okay. We know that this is my V naught. Now, if I say that V naught will be past the current, so one direction of current will be this one, and one direction of current will be this one. So we are getting some drop across this resistor, and that drop is called VA. Okay. Now the second operation amplifier is negative feedback, and we know that because of the virtual ground concept, VA and Vx both are same. So because of this second operation amplifier, we are getting the output of the second operation amplifier, and because of that one, we are getting this Vx. Because of this first, we are not getting Vx, but because of second, we are getting Vx. Okay. So current is not passing from the operation amplifier. So because of this volt, we are not getting Vx, but we are getting V out. Now V out will be drop across this resistor. So here it is some voltage, and that voltage will be Vx. Okay, so because of second operation amplifier output, that is current is flowing from the output to the ground. So because of that one, we are getting this Vx. So don't be confused that I say that first operation amplifier is not working because it is a negative feedback. So how we get the Vx? Vx is not 0.
Yes, sir. Understand.
Okay. Any doubt other? Yes, any other doubt? Week 2. Practice assignment. Any doubt? Week 2. No doubts? Week 3. Just wait.
Sir, sir, can you explain what is AC coupling? Like,
Yes, any doubt? Week 3.
sir, AC coupling.
Question number?
Sir, it's topic AC
Okay.
coupling. What?
Okay, I just note down the topic. Any doubt related to the question? First of all, we do that. Any doubt related to the graded assignment and practice assignment for week 3? Week 4? Any doubt? Week 4 graded assignment, practice assignment? No doubt? Week 4 graded assignment 2. Okay. Hmm. Okay, the question is hmm, the output voltage of the circuit shown below is the forward bias voltage drop. Okay. Okay, so the output voltage they are asking. Okay, so this is the question. Now the thing is that if you go with the week 4 content, so we are using the formula with the diode. Okay, that particular diode will be the Mhm. Okay, so we use the diodes. If you remember, with the derivation is VD1 diode voltage is KT by Q ln I naught by wait a minute. What is that? Yeah, the equation of the diode current I naught is equal to IS e raised to power VD upon NVT. Okay, so that one is I naught by IS. Similarly, if I say that VDN, so this is the combination of N diodes, so we use the KT by Q ln N I naught upon IS. So VD1 minus VDN, we are using the formula KT by Q ln of N. Okay, now they are asking the voltage in the circuit shown in the figure below if the forward bias voltage. So they are giving the VD1. Okay, so VD1 they are giving the 0.7 volts. Now we have to calculate the VDN. So VDN is equal to VD1 minus KT by Q ln of N. So that is 0.7 minus KT by Q at the room temperature 298 is what? Around 25.8 millivolt. You put the value of K is Boltzmann constant. Okay, so K is 1.38 into 10 raised to power minus 23. Q is 1.6 into 10 raised to power minus 19. And T is given as that is the 298. So KT by Q and we calculate. So it is around 25.8 millivolt. Okay, so 25.8 ln of N. Okay, and we have the 8 diodes. So the value of N is 8. So 0.7 minus 25.8 into 10 raised to power minus 3 into ln of 8. So if I calculate that one, so ln of ln of 8 is 2.079 multiply by 25.8. So it is a 0.7 minus 0.053. So the value is 0.7 minus 0.053. So it is a 0.053. 647. Okay, 6.6 or 647. That is the my this voltage. Okay. Now VD, I just say that this is a 0.7. This is the 0.647. Now after that we apply the formula. So this is my voltages. So I just apply the superposition. Either I can apply the superposition. So if I say this voltage is applied, so V1 is nothing but V out one is nothing but 0.7 times 1 plus RF by R1. Okay, because 0.7 voltage, one diode will be connected on the non-inverting terminal. So 0.7 times RF by R1. So I8 by, so that is 3, so 2.1. Okay, and what is V out to? 0.647 times again RF by R1. So that is minus RF by R. So 0.647 times minus 2 by 1. So we are getting 1.294. Okay. And overall voltage is what? V out is what? 2.1 minus 1.294. So that is 2.1 minus 1.294. So it is a 0.806. Okay. Now any doubts? Yeah, so that is we can use the formula, na? So that is nearby 0.7 volt, but what is the exactly value of that? Because of N is equal to 8 diodes, so we use the formula. And what is the formula? KT by Q or VT log of N. Okay, and this particularly value, if we subtract from the VD1, we get the VDN. Any other doubts? Week 1, 2, 3, 4. Any doubts related to the graded assignment, practice assignment? Can you ask? No doubt? Okay. So now we go with the that topic, AC coupling. So Just a little bit brief about that one. The briefing of that is we have the operation amplifier. That will be work on a to supply plus VCC or minus VCC. This is the particularly terminal. Either this is the VI. We can use this is the positive terminal. Okay. On the negative terminal, ground. This resistor, this output voltage, and what we are getting is V out is equal to VI 1 plus RF R1 RS. So 1 plus RF by there is no effect of the RS. But the problem with this operation amplifier working is if we implement with this circuit into the circuit, so we require two supply voltages. Okay, if my VCC is 5 volt, so what I do, I have to create a plus 5 volt as well as the minus 5 volt. And for the independent circuit, what should I do? There we have a 220 volt supply. Okay, in the power supply that are available in our laboratory, they have the plus 5 volt and minus 5 volt. But if we are going to implement one independent circuit and that will be operate on a normal supply, electric supply, so we know that that 220 volt will be coming in our houses. Now that particularly voltage will be, I have to convert because this is the AC signal. I have to convert this one in the plus 5 DC and minus 5 DC. Okay, so what should I do? I just convert a 220 volt initially to 5 volt AC. Then this 5 volt AC, I just convert into the DC of 5 volt. Okay, but there are some spikes or some pulses are there, so I just convert into the regulated DC. 5 volt. Okay. Similarly, if I require the minus 5 volt, so again till that no issue, but after that I just use a 5 volt minus 5 volt and again regulated DC with the minus 5 volt. So we require two independent, two different circuits that will be generated plus 5 volt and minus 5 volt. So basically my circuit is complex. So what should I do? I just convert this particular into the single supply. So I just add a plus VCC here and plus VCC here. Okay. So what the thing is happening is if I just boost my level or basically supply voltages by the VCC, so my output voltage I also boost up. Why? I just take an example. Initially, my operation amplifier will work in minus 5 volt to the plus 5 volt. Okay, so that means my output should be in between the range of minus 5 to plus 5. Clear? I assume that my output voltage will be the minus 2 volt. But when I change the supply, so now I add a plus 5 volt here and plus 5 volt here. So my supply will be now 0 volt to 10 volt. Okay. In that scenario, if my output is again minus 2 volts, so that is the invalid output. Why? Because output always lies within the supply range. So for converting that one into the valid situation, what should I do? I have to add the output voltage by the that particularly 5 volt. So my output now becomes a 3 volt and that is in the valid condition. Okay. So the thing is that I have to add the output voltage also. That particular supply voltage I have to add into the output voltage for a valid output. Now, how we get this output voltage as a V out is if I create a circuit. This is my plus minus, and this is my Vi. Now, what should I do? I just add the V out here. Okay, so what is the benefit of that one? This is the RF, this is the R1. So what is the benefit of that one is my output voltage will be changed Vi plus V out times 1 plus RF by R. Okay, so that is the Vi plus V out plus Vi RF by R1 plus V out RF by R1. So four terms we are getting. Now I just common this one Vi. So Vi 1 plus RF by R1 plus V out plus V out times RF by R1. Okay. Now you can see that this is my output voltage, and what is the output voltage we are getting? Vi 1 plus RF by R1. So that is the output voltage V out. Okay. To convert this output voltage into the valid state, what should I do? I have to add a V out. So my V out will be added in this one. So these two are the desired output. But along with that, one term is also there, that is the not desired. So I have to eliminate this term. I have to eliminate this term. So what should I do? If I subtract V out times RF by R1, so that particular term will be cancelled out. How this term will be added? If I add this particularly V out supply here. So because of the inverting terminal, what is the output at the V out? Minus V out RF by R1. So this is term it will cancel out because of adding here. Okay. So now all problem will be solved. Is it clear?
Yes, sir.
Now the thing is that if we have my supply signal will be like that. This is the VCC, or we can say the two VCC, and this is the ground. So I just use the Vi plus VCC. That is the V out plus VCC. The level that we boosted, everywhere we add this particularly VCC. Okay. Now again the thing is that Vi is a 1 voltage and VCC again the 1 voltage. Okay. Or if I say replace it by the VCC and ground, so that is the VCC by 2, VCC by 2, VCC by 2. Okay, so we require three terms, three voltages. One is the VI, second is the VCC, and third is the VCC by 2. Again, one volt. So VI is okay. VCC we required a 5 volt. VI is that is dependent on the input signal. Input signal is anything. Either it is my voice, either this is the some other signal. Okay. So that VI is okay, VCC is okay, but again we have to generate the VCC by 2. How it is possible? So the problem is again same. In the previous case, what we do, we are generating the VCC and minus VCC, or VCC by 2 or minus VCC by 2. Now this term we are getting the VCC and VCC by 2. 2 voltages here. So again the circuit is complex. So what should I do is that I use one battery in place of generating this voltage in the circuit. I use one battery here. That will be the VCC by 2, VCC by 2, and VCC by 2. Okay. Now the problem is that the battery voltage is also not a constant. So sometime we are getting the VCC by 2, sometime we are getting, because if I say this is a 5 volt battery, so after some time the voltage will be start reducing to 5, then 4.9, then 4.8, then 4.7, 4.6. So the voltage will be start reducing. So we are not getting a constant voltage here. This thing is constant, that is a 10 volt and ground. Why? Because this particularly voltage will be generated through the AC signal. So that voltage is constant, but battery voltage is not a constant. So what should I do in this scenario? In place of battery, can I use a capacitor? Because the problem with the battery is that battery will be discharged, then after that you have to change the batteries. Okay, so in place of the battery I use the capacitor. So everywhere I use the capacitor. Okay, to convert this VCC V naught plus VCC by 2, I just use a capacitor, or basically the opposite polarity battery, to get the V out. Okay, so we use one capacitor. Okay, so everywhere we are using the capacitor, but the condition, there are some certain condition for the capacitor, is capacitor charging and discharging time. Tau charging and tau discharging. That particularly time will be dependent on, or basically function of, the capacitance and the resistance connected with that. Okay, because I think you are aware that tau charging is 0.693 RC, like that one value. Okay, RC or 0.693. Basically, if you remember the RC circuit that you discuss in the ESTC or EEC somewhere, so there is a time constant tau is nothing but RC. Okay, e raised to power minus t upon RC, if you are remembering that term. Okay, so basically this is the time constant. So that means charging and discharging time is dependent on the value of resistor and capacitor. Okay, so we have to choose the value of capacitor in a way that my charging time is less and discharging time is high. That means it will be charged very fast, but when we are using that one, so basically discharging rate is very slow, so it will be long lasting. Okay. Now this capacitors is called the coupling capacitors. Okay, this capacitor is known as the coupling capacitors. Again, the thing is that initially the capacitor will be charged by VCC by 2. After that one, it will be discharged across this resistor. Okay, so we have to connect one circuit here that will be used to charge when the capacitor will be basically discharged up to a certain level. After that, it will be used to charge that capacitor. So what should I do? I just connect a voltage divider biasing here. Okay, so we are getting this voltage at the VCC, same voltage, one resistor, then one resistor. Okay, and that voltage is constant. So the voltage drop across this resistors, if this both resistors will be the R and R, so that means downward R, the voltage drop across this one is the VCC by 2. So that particularly voltage will be used to charge the capacitors. Okay. Now if I go through with the internal circuit of that one, so we have VI. Hmm, sorry, if we have a VI, along with the VI, we are having the RS, then capacitor, then this voltage VCC, R and R. Okay, so now the voltage at this point is, what is the voltage at this point? If this is the VCC, this is the R and R grounded, so, and this is the joint. So basically the voltage drop across this resistor is VCC into R divided by R plus R. Apply the voltage divider biasing. So that is the VCC by 2. So because of this VCC, we are getting the VCC by 2. But because of this VI, we are also getting, okay, this voltage. And what is that particular voltage? The voltage drop across this R. So plus VI time R by 2 upon R by 2 plus RS plus 1 by CS. Any doubt? The voltage, basically the current will be going in this path. Okay, so the drop across this one is the resistance, overall resistance, and the voltage drop. So VI is the input voltage multiplied by the resistance upon overall resistance. Okay, so
Okay,
we
sir.
are getting that if I say this is my V out voltage, so V out upon VI is what? Okay, now the condition is that the RS is very less than RX by 2. Why? Because RS is the voltage or basically source input resistance. We are assuming that the source is ideal, so the RS is 0. But if we are not using the ideal condition, so the RS should be the minimum. So the value of RS should be less than RX by 2, or basically R by 2. We are saying the R by 2. Okay, so in this equation, I just use this term So VCC by 2 plus VI times R by 2 upon R by 2 plus 1 by CS. Okay, and because of this CS component, that particularly output voltage is function of frequency. Okay, so that particularly V out is function of a frequency. So this particularly frequency dependency is called the AC coupling. We can't couple that particularly signal as a DC. Okay, why? Because for the DC circuit or for the DC, if VI is the DC signal, so the capacitor behave as a open circuit. We know the impedance of the capacitance XC is 1 over j omega C. So if omega is 0, the frequency is 0, so Xc is infinite. So if Xc is infinite, we can say that no current will be pass. So that particularly capacitor will protect that no DC component will pass from the input to the operation amplifier. Only the AC signal will be passed from the input to the operation amplifier. So this capacitor will ensure only the AC coupling will be done in the input of the operation amplifier. So that's why it is called the AC coupling. Okay. Now you can calculate the frequency also using this function. You know that what is the magnitude V naught upon Vi. Okay. Now I create the magnitude and calculate the frequency. Calculate the magnitude part and just put the value so you can calculate the frequency of it. Okay, so the condition is that the capacitance value, I think that should be greater than 1 upon omega RL, or the frequency we can say omega should be greater than 1 upon RL times C. F should be greater than 1 upon 2 pi RL times C. If I say the minimum, so F should be equal to 1 upon 2 pi RL. So this is the minimum frequency of operation. Okay, that is the condition that F should be greater than 2 pi RL C. But what is the minimum condition is that F is equal to 2 pi RL times C. Sorry, RL times C. So this is the minimum condition for calculating the frequency, input signal frequency. Okay, so this is the AC coupling. Any doubt? Okay. Anything else you want to ask, you can ask. I can't hear your voice, Madhusudan.
Sir, can you share mock?
Mock, yeah, I will share that one. So I think tomorrow they will release the mock test. Okay.
Okay, sir. And sir, uh,
Yeah.
the quiz one questions is similar to graded assignment or hard, like which type of question?
Some of the similar types we have it. I think we have given 3 questions. Okay. The concept is almost similar. Okay, if you cover the week 1, 2, 3, 4 properly, so I think you will be able to calculate the answers. No worry about that one. But thing is that if you understand the concept,
Okay, sir.
then you can easily solve. But if you are only just doing the last time assignment or basically asking the answers with some friends and putting that one in the graded assignment, so it is quite typical for you to solve that.
Okay, sir. Yeah, understand.
Okay. Anything else?
No, sir.
So then we stop.
Thank you, sir.
Yeah. Thank you. Anytime if you have any doubt, you can ask.